3 Mustangs, so you can never go wrong with these. So we've got the Mustang 1000, he sent a Mustang 2000, and he sent the Mustang 3000, which you don't see many of. Don't think there's any mics in the package, so we'll just use one of our standard ones, and we'll see what's happening in here. So it's going to be boring for you to see 3 more or less identical sets, but that's sometimes how it goes, and I know that you're wanting to see repairs rather than our original idea of just doing one of each set and then leaving it at that. Take both the lids off, I think, this time. Have a quick inspection. Okay. We'll get the isopropyl alcohol on that bit there. I don't like to see ballast resistors that small. They really need to be higher wattage than that, and I think we also need to change that capacitor. It's starting to recede its heat shrink cover. Whether or not that's just the vicinity of it to the output transistor and the ballast resistor, I'm not sure, but I think it's had quite a hard life, so I think I'd like to change the ballast resistor and the capacitor there as a safety thing. I also like to look at the protection diodes and just feel that they're not cracked. I haven't got sockets for these anymore, so we'll just poke around with our crocodile clip lead. There should be a standard mic on this bench, and it should be that one. There's a lot of should be's today. Made in Japan, serial number 989. Switch the power supply on. Switch the radio on. Last on channel 14. Plug in the mic. And it does light up red in the meter, which is what's supposed to happen. It's always nice. I think the D'Amico Convoy does that, doesn't it? So, using the Cybernet 002 chassis, sometimes wrongly referred to as the Amstrad chassis, important fact about these is setting up the VCO. I think we'll write down how it's working on a piece of paper. Here's an old Bible reading left over from church. So we'll start off by writing down Mustang 1000. I notice it's sent a York 863. This isn't Mr. Immaculate, but I tell you what, his set's usually pretty smart looking. I think he's buying them from eBay, and he's being rather choosy. But sometimes you find that really smart looking sets. They're smart because they've not used, because they've not worked. But that doesn't mean much because we can sort them out usually. So we'll start with transmit. And we are getting, are we on picture in picture? No, we're not. So we'll just switch that on. There we are, I have switched on picture in picture. And it's doing 2.9 watts. TX, 2.9 watts. Deviation, are we still tuned in from yesterday? No, we're not, because we're doing that CPT set yesterday. Wow, oh my goodness, it's... Wow! Oh no, I was on the wrong scale. Wallow, it's 1. Forgotten about the Roger Bleep. 1.7 kilohertz deviation. That needs to come up. Sometimes people disable the Roger Bleep, and I usually ask the customer if they want it re-enabling or not. So I wouldn't automatically fix that if it came in disconnected, because it annoys some people. So let's look at the how well on frequency it is. Should be 27.79125. 27.79120. That's really spot on, isn't it? But we'll just pull it up if we can. Now these are 20-something years old. Sometimes the reference crystal is starting to go beyond what it can trim. At least you can trim it, unlike the Uniden sets. And that is the absolute top of the shop. 79122. So that is it. It will not adjust any more than that ever. I think we're going to change that ballast resistor. We're not going to even look at the tuning to the transmitter. We'll just change that ballast resistor for one which is higher dissipation. I mean, think about it. If you've got 2.5 watt resistors, or are they 3 watt? You know, it's not going to do much more than 3 watt, is it? But without those cooking up tremendously, which is why we put the 6 watt resistors in, 5 or 6 watts, so it's on top of the job. Otherwise, you're never going to dissipate the power that it's supposed to be doing. I think you're supposed to set it at 3.8 watts, but of course we set them to 4 because we're not having to get it through customs. So let's go for it. We'll get the multimeter out. Now this is going to be fun. I normally connect it to the I think these are floating earth. So if I put my positive prod onto the protection diode positive, and we go to one of the cans, we've got rail voltage. If we go to the chassis, we haven't got rail voltage, so I'm correct in remembering on this occasion that we have a floating chassis. So what we're looking to do, I'll just pop that onto that, the negative there. And so we're looking at the far side of capacitor 9. So the first thing they want us to do Well, the first thing I wanted to do is put it on frequency, which we've done as close as we can. So we go to channel 1, and in receive we're just T1, which is that, until we get 2 volts. Now these are never as per manual, and to be honest, you're probably supposed to use an AVO 8 meter at the time, and I do have one here, but I really can't be bothered to get it out. So we've got 2.23, so I think we just need to lower that a fraction. There we go, that's now lowered. Then when we're going to transmit, we should also have 2 volts. And it's just marginally out, so it's the red trimmer for transmit. So there we've got transmit. We look at this meter, I'll go to camera 1, and on receive we've got 2 volts as well. And then just to check it, they expect us to go to channel 40 and not pull the negative lead off the radio. Sold me last Amstrad lead to somebody for $2.99. That was silly, wasn't it? Right, so we're on channel 40. And they're wanting transmit to check that it's about 4.5 volts. And that's what is normal. I don't know where they got the 4.5 volts from in their manual. And there we have receive, so it is in lock. So never worry about not getting that 4.5. Set the low one to what they say, and as long as it's in lock. When you start worrying is when you've got minus figures there, because you can end up with minus figures, and that's when you start dropping channels out. So put it back to channel 20, and that is fine. Now we'll get on with this ballast resistor. Here's a nice bag of them. I think we're going to have to reorder these. This is the last one of the right value. I'll just keep that CPC bag on one side. Probably ordered them from RS anyway. Hoping there's a little file on here. Well, there's supposed to be a little file on here. Anyway, I'm going to swap that, and I'm going to swap that capacitor. So I'll pause the video. Right, so a few minutes later we're back with a new ballast resistor and a new capacitor. Out of interest, let's see whether the capacitor's any good that came out before I throw it away. Once you start seeing the heat shrink receding, you know it's time to wave goodbye. And what are they, 16 pence or something like that? Reads fine, 47 microfarads. In the bin it goes. I just don't like that arrangement. Those are too lower value when you compare to what we put in. So I've not done any adjustments whatsoever. So let's see now what the transmit power is. Helps if we switch the radio on. Helps if we switch the power supply on. Whoa! It's 4.1 watts. I'm not going to touch the tuning, and that way we're not going to be having to get the spectrum analyzer. That's never been touched. So we've just gone from 2.9 watts to 4.1 watts. just like that. I'm allowed a 10% measuring error, and that's fine. So we'll just check how that is over the 40 channels. So on channel 40 it's 4.1 watts, on channel 1 it's 4.1 watts. So at 13.8 volts we're doing 4.1 watts. So just going to turn the power supply down. I'm going to turn it down to 12 dead, and we get 3.2 watts. Yeah, 13.8 is 4.1. Good, well, that sorted the transmitter out. Out of interest, we'll see what it does on low power. And it does 0.32 watts. So the next thing we better alter is the power meter. So we're going to transmit, and it's banging across. So we just need to drop that back so it's in the centre of the red section, right into the middle of the strawberry patch. Good, that's the transmit done. It's a nice radio. So then we're going to the receiver now. So I've got my cyanide meter on. We'll set this frequency. Spray those controls. A little bit of noise there. Sometimes controls are sealed types and you can't spray them, and then you can't replace them, and it's a nightmare. Okay. So we never did check what it was doing before I touched it, so we'll just look at the cyanide to see what it was doing before I touch it. So that's 12, that's not quite 12, that is 12, about there, and it's doing 0.31 of a microvolt. 0.31 microvolts for 12 dB cyanide. So that's now 4.1 watt. Oh, we never looked at deviation. That's why I have these tick off lists. So get a little oscillator out, just sort that out. So go back to transmit, put that back on. It needs to come up, even though you wouldn't have thought so looking at that. That's because I'm in the wrong mode. Let's see how that is. Testing what? Wallow. There we are. 2.2 to 2.5. Go back to where we were. So that is absolutely fine. I'm not expecting us to get that any better. It'd be funny if we got it worse. So we'll put an S9 signal on the signal generator, which is 100 microvolts for CB in the UK. We'll have a look at the oscilloscope, which looks awful. I'll turn the bench light off so people can actually see it a bit better. And we're just going to see if we can maximise that trace. Except that's the wrong coil, it's that one. Whoa! Miles out. God, I bet this was garbled and quiet. Excellent. So we'll just go through the others with the cyanide meter. But I think it's all spot on, it's never been touched and messed with. It's the wrong one. Try that one. Spot on. Spot on. Put a bit more signal on for these. That's the one I upset. So now we've got, 0.27. So that's that done. So looking at the signal meter, so I've put S9 back on. Oh, look at that, it's bang on. No, that doesn't need touching at all. If it did, it's the preset there. Now squelch, that's bound to be. This is the letdown on this chassis. And you can end up with the squelch set so that with the aerial not plugged in, there's no noise at all because the squelch comes in. It is the letdown. But we'll just treat it as conventional for now. Put the squelch to full, and I want it to come in at 100 microvolts. Okay, so now we'll go to the other end, set it for threshold. I'll put the attenuator controls on the display. So we'll turn the signal generator to standby at 0.3 microvolts. We're going to turn the squelch down on the radio and set threshold. Switch the signal generator on. It's come straight in. So it's coming in at 0.32 of a microvolt, and it's disappearing off at 0.15 of a microvolt. And then I'm going to turn the squelch down, switch the signal generator off, and unplug the signal generator. So we've now just got nothing. And it is hissing because sometimes he's going to mute. And then people don't think they're working when they are. We're done. So I'll just make a note here, because he sends about 6 sets in. So it's 47 microfarad at 16 volts and 3R3 6-watt resistor. Of course, I can't remember which lid you put on first. I can't remember which one's negative, not that it matters. how weird is this? I'm not getting earth on any of them. Yes, I am. So the green one is the earth, like you'd hope it was. Now sometimes these speakers can go bad, so let's have a listen. At least we've got suitable speakers for CBs in stock again. That sounds alright. So we'll pop that back together. It should have gone on first. Put the service manual to one side. It's nice to see a radio that's 38 years old and hasn't been messed with. When we can get the screw holes to line up. I probably told you about the missing church organ part. I'm installing a small organ at a church near here, and 4.5 miles away. And you know, it's a pipe organ which we're selling them and installing, and just coming to put the last part in. Can I find the last part? No, I can't find the last part. So I spent 3 hours today, 3/4 making the missing part. So tomorrow I'll put some stain on the bit of timber and glue the 2 pneumatic motors which I've made today onto the counterboard piece of wood, and hopefully we can then install that later on in the week. I booked hopefully to tune the organ there tomorrow, because there's a service on Sunday. It's been playable for quite some time, but with COVID, not really been able to finish it off. It would be nice to finish it off. I could probably send them an invoice then. Turn the test set off. That's powering up. And we'll put it on the roof aerial. People keep asking about this roof aerial of ours, and it's a Antron 99 type of fiberglass thing. There are other makes that do a similar type. It's a single-story building, and it's mounted just higher than gutter level, and it's fed with thin cable, 6mm, but is industrial grade for 2 gig mobile phone installations. So our thin cable is like a lot of people's thick cable. So let's have a see. 19 Roger. 19 Roger. Roger breaker. He didn't hear me. Expect he's got his burner on. Somebody on 40. I know this is going out 35 miles, so you know, I know what our range is from here. Right, so that is ready to do an on-the-air test with Mr. Chippy, and so I think someone's had the coffee mug on there. So that's a nice radio, and it's double nice to have brought it up to full power, slightly more than full power. Right, thank you for watching the Mustang CB1000, and if the customer's correct, tomorrow it will be a Mustang 2000.